Hello, ladies and gentlemen, and welcome to our first ERCI webinar in 2024. And maybe it's too late, maybe not. All of you, Happy New Year. First, I ask all of you to mute yourself so that we can smoothly start. The topic of our first ERCI webinar is using satellites for improving the safety in rail. And who of you who have not only attend one of our ERCI webinars, I want to introduce you shortly what ERCI is. ERCI network is a network of 17 rail-related clusters, which are covering 16 European countries, was founded in 2010, and is a legal entity based in Brussels since 2022. All of these 17 clusters covering just a moment, are covering enterprises, most of them small, medium-sized enterprises, over 1,500, and another research institutions, accelerators, incubators. So we are a bit too fix with our presentation. So I will come back to the essential contents of that slide. What is our task? What is our mission? It is to enhance the visibility on European level for the enterprises, mainly small, medium-sized enterprises. It's partner matchmaking in research and development projects. It's support for small and medium-sized enterprises. It is our annual ERCI Innovation Award. We also will performing this year. And it is the discussion of innovative topics due to ERCI task forces like on cybersecurity, multimodal logistics, green and sustainable mobility, and human factors. And we have bilateral workshops and webinars like this one. And that is the main service we can provide to European enterprises of the railway industry in Europe. So these are our contact data. You can easily follow us via our website, via X, formerly known as Twitter, via LinkedIn, and for sure we have also an email address. So we will start now with this first presentation, and I first hand over to Guido Ancarani. He is one of the cluster managers of DTEC Fair, our Italian partner cluster, and he will introduce you the first presentation. Guido. Guido? It's the microphone.
Exactly. Good morning, everybody. Thank you, Lutz. Yes, I would like to introduce the first speaker, who is Francesco Di Bartolo. I will say that he took his master degree in biomedical engineering in 2017 with a specialization in information technologies and then a PhD in biomedical engineering at the University of Pisa in 2020. After the PhD, he worked at the Civitanavi system in the manufacturing engineering division, where he acquired a strong knowledge on inertial and GNSS navigation. Then, since March 2023, he has been working as GNSS engineer at Intecs Solutions in the aerospace division, and we appreciate his sharp involvement and contribution in the ESA Space for Life project. This is the topic of today. So, after this brief introduction, please, Francesco, the floor is yours.
Thank you, Guido. I will share my screen. Okay. So, hi everybody. As Guido said, I'm Francesco Di Bartolo, GNSS engineer of Intecs Solutions. I'm going to present a project named Space for Level Crossing Safety, which is aimed at increasing road user safety at level crossings through space technologies. This is a project co-funded by ESA. The prime contractor is my company, which is a high-tech company delivering cutting-edge solutions across a wide range of markets. And the subcontractor of the project is Detecfer, Guido's company, which is a non-profit company with a big expertise and consolidated international experience in the railway sector. For what concerns my company, we work in a wide range of fields. We have in particular some divisions, aerospace, artificial intelligence, automotive, railways, division dedicated to products, and we also perform consultancy services. Intecs has many certifications. Some are listed here. Some of them are not renewed, but because the market does not request them. But of course, there are the basis to renew them. Okay, so now a brief overview of some projects, some ESA projects where we are involved, based on space technologies. We have GPassion, which is a SDR-based solution aiming at authenticating Galileo OS positioning service. Then Jasone, which based on the development of a GNSS surveillance segment providing services of local and regional monitoring of the GNSS signals. Emuser, which is based on the development of an innovative obstacle detection system integrated with a satellite broadband link for improving the safety at active level crossings. And then Aegis for Rail, which is a very innovative solution to retrieve the train absolute position, exploiting GNSS, but also ground sensors. And then we have Space for Life that I'm going to present. But how was Space for Life born? To answer to this question, we have to analyze the context. Level crossing related accidents are the second cause of railway related fatalities worldwide, not only in EU countries. Indeed, according to statistics of the agency, of the European Agency of Railways, we have that the 30%, about 30% of fatalities on railways are related to level crossing related accidents. And most of road users involved in this kind of accidents are basically cars, pedestrians, and heavy vehicles such as trucks or big vans. High costs are related to railway accidents. Indeed, Europe spends about 3.2 billion yearly for this kind of accidents, and about 1 billion only for level crossing related accidents. So it's a quite big issue. This topic. In particular, most of the costs are related to fatalities because unfortunately railway accidents are connected to a big amount of fatalities, and then also costs related to train delays and also damages to infrastructure and environments. Which are the causes of this kind of accidents. First, we have to address to the type of the level crossings. Indeed, in this project, we distinguish two categories of level crossing: passive and active level crossing. Active level crossings are the one which have protection systems such as barriers, half barriers, or even manual barriers or flashing lights. Passive level crossings are level crossings without any protection systems, but just some road signage to signal the crossing. So this one. So basically, in Europe, most of level crossing are active, as we can see from this plot. However, still more than 40% of level crossings are passive, which is actually a very high percentage. Thus, statistics suggest that the safety measures at level crossings should be improved to decrease crash occurrence. And the project scope is basically to improve the safety standards of road users through the design of a system based on space assets and cutting-edge informatic technologies, providing help to road users with their decision-making process in approaching and crossing level crossings, help railway managers with the optimization of level crossing maintenance work, and also data sharing between users on eventual level crossing issues and other crucial pieces of information. So the main objectives of this project of Space for Life are the definition of user requirements in accordance with the road users and stakeholders, system architecture design with a deep analysis of technical and economic feasibility and viability, and the definition of the implementation roadmap to bring the system to market. So let's start with the first objective. First of all, the first activity was stakeholders' engagement and collaboration. And among the stakeholders that we engaged, there were three railway infrastructure managers from Germany, Norway, and Italy, and ANSFISA, which is the Italian National Agency for the Safety of Railways and Road and Motorway Infrastructures. Basically, the main outputs of the collaboration with them was the validation of the user needs and user requirements that we defined, and also some important tunings of them. Then some observations are there that railway infrastructure managers were interested in maintenance, level crossing maintenance services of the system, while ANSFISA was very interested in services aimed at improving road user service, road user safety. So we can see like the different approach of these stakeholders. Then we also involved in the project the road users through a survey, a multi-language survey that we wrote down in Italian, English, German, and Romanian, that we spread out on the web to map the different experiences, behaviors, and suggestions for improving the road user safety. It was a very nice way to retrieve user and validate user needs and user requirements, because actually from this survey, one more user requirements related to the need of optimizing the on route based on active level crossing closure has been identified. Then road user needs and user requirements basically have been defined based on state-of-art analysis of the statistics at road accidents, but also through a study of the decision-making process before basically a road accident. The model that has been taken into account was the Rasmussen's model, and it has been adapted to level crossing related accidents. It consists on 5 steps, and for each decision-making process step, we can identify a specific error. And by analyzing each specific step and each specific errors, we defined basically the user needs of our system of space for life systems. Basically, we defined 7 user needs, which have been collected starting from 4 system use cases. And from such user needs, we defined 14 user requirements. Then we go to the second objective of the project, system architecture design. Here we can see high-level architecture, a high-level representation of the architecture of the conceived system. It is a cloud-based system. We have a cloud control server, which is connected to 2 applications, one for rail management entities and one for road users. Then there is the possibility to download and process satellite Earth observation data through the cloud control server, and there is the possibility to localize road users through the GNSS technology. Also, we added some additional ground technologies, such as optical cameras, that could be an help to the space technologies in providing higher safety standards to road users. But the ground technologies are just an optional, some optional elements of the systems. For what concerns satellite technology, for what concerns satellite technologies, they are the key assets for driving road users to take safely action at level crossings, and for a high optimization of level crossing maintenance with effort and cost reduction. And making a focus on such technologies, GNSS is typically the key element for road user monitoring by means of the dedicated application of the system. GNSS is very good for monitoring road user because it's easy to use and low cost. And also it's a very common technology. Indeed, GNSS sensors are present in all smart devices. Then we have satellite Earth observation, which is the key element for remote and periodic monitoring of active and passive level crossing surroundings, especially for passive level crossing surroundings, which nowadays are not effectively monitored. Providing information about train visibility at passive level crossing through the monitoring, for example, of vegetation growth. We can say that if integrated with super resolution algorithms, we can obtain also high resolution at low cost from the free Earth observation images. Okay. Then here the services provided by the systems. Here we have the primary, let's say the primary system services, which are provided thanks to the space technologies then, so GNSS and satellite Earth observation. We have the real-time monitoring of road users' positions in proximity of level crossings with the related alert service to road users to suggest them how to correctly behave at the road users. Monitoring of level crossing surroundings in terms of vegetation growth, flooding, and other major issues with alert service to rail network management entities for the optimization of level crossing maintenance, especially at passive level crossings. Then we have another service, which is the mitigation of the consequence of unavoidable level crossing related accidents, where we suggest to road users which are the correct action to do if they get stuck at level crossings, with also the opportunity to take an emergency call. Then we have the creation of a risk scale and assignment of a grade of risk to each level crossing as a function of static and dynamic parameters, with delivering of such parameters to the entities responsible of level crossing maintenance. These services is related to a better optimization of level crossing maintenance. Then the processing of data coming from space assets, GNSS and Earth observation, recovery of information related to level crossing status, and warning to road users and rail network management entities if some issues are detected. Then reporting service, which road users can report encountered level crossing issues to railway managers through. And then the provision of ad hoc applications to all users for data sharing and level crossing alerting service availability. And finally, the monitoring of railway traffic for road user route optimization in case of level crossing closure. Then you have also a brief list of optional system services provided if ground technologies are installed at level crossing, then optical cameras. We have the real-time monitoring of the surroundings of the most critical level crossings for statistics purposes, and as a more robust update of the level crossing rates of risk, the monitoring of train arrival at active level crossings, obstacle detection on the level crossing tracks and eventual alerts to train network management entities, and alerts to road users about the presence of passive level crossing through the installation of warning signs. This service would be useful if the users do not have smart devices, or if the level crossing is placed in remote places where there is not internet or GNSS coverage. The possible constraints of the systems are basically the satellite Earth observation data resolution. Indeed, free Earth observation images have a poor resolution, thus for an effective monitoring of level crossing, commercial Earth observation images should be exploited. Then the internet and GNSS coverage, indeed in some remote places, for example in valleys very close to very high mountains, or also in cities where there are a lot of skyscrapers, maybe the GNSS coverage, even the internet one, could be poor. The reliability of alerts, which is related to the internet and GNSS coverage, the user speed and time constraints versus alarms. Indeed, if the road users go very fast with the car, maybe the alarms can arrive late to the road users. Then information about railway lines and level crossing characteristics. Indeed, for example, the railway infrastructure managers in Italy, RFI, told us that the information about the level crossings are not in digital form, and so the retrieve of such information could be very hard. And then information about level crossing closure, because we would take the information about the train position from external providers, and maybe such external providers could be not that accurate. So through a deep analysis of such constraints and all the possible major failures of the system, anyway, the system proposed in Space for Life results not to be safety critical. From the use cases, the 7 user needs and the 14 user requirements that we defined, we arrived to define a total of 63 system requirements. Then we go further to the last objective, the definition of the implementation roadmap. Here we started actually from the analysis of the strengths, weaknesses, opportunities in the market and threats of this system. Among the strengths, we have the low cost of the system, a low cost level crossing maintenance and management, the decrease of level crossing related accidents. Among the opportunities, the links to other satellite-based projects, also the link to railway signaling systems such as ERTMS, and also application in other sectors such as tramway in urban context. For what concerns some threats related to this system would be the unavailability of satellite Earth observation images, but also their resolution, the internet and GNSS coverage, the predominance of human factor in the last decision, because the system is just a help for road users, but the last decision, the last action is totally human. The weaknesses are basically two, which is a non-safety solution, and it does not cover level crossing misuse, because the last action is human. Then, for what concerns the benefits, we would have the decrease of railway-related bringing high-level economic benefits to both railway managers and stattal entities. Railway managers, because of level crossing maintenance optimization, which implies a save of costs, a decrease of cost. For the stattal entities, through the decrease of hospital admissions, emergency calls, and use of special emergency vehicles. The market segment would be both EU and non-EU, because this kind of system suits well for railway systems which are quite consolidated as the European one, and also for non-consolidated railway infrastructures, which has many non-European railway lines. Infrastructures. So, just to conclude, Space for Life proposes the development of a low-cost system based on space assets, GNSS and Earth observation, that would be well suited for both a non-consolidated railway market, being economically sustainable for both EU and non-EU markets. So, Thanks for your attention. And here you can find my contact. And of course, questions are welcome.
Thank you very much, Francesco, for this presentation. I'm very glad that DTEC, the Italian Railway, is a part of this project with you, because we believe that this is one of the future lines in Europe that we have to follow. I remember the words of Carlo Borghini of Shift2Rail, Europe's rail joint undertaking, saying satellite will be one of the assets in the future of Europe Railway. So let's see the question that we have already collected for you. If you can shortly answer to all of them in order then to leave the space to the second speaker. The first question is an integration of space for life system to be expected into the railway system?
Right now, it is not expected an integration on the railway line system because basically Space for Life is not it's like a non-safety system. It's a non-safety system because it just it's a warning service to road users to help them with their decision-making process at level crossing. It's not, let's say, a control system who say to road users what to do at level crossings. Indeed, it does not provide, for example, a very accurate position of the trains at level crossings to say road users if they can go ahead and cross the level crossing or if they have to stop. It's just, let's say, warning systems and also a system for the optimization of level crossing, of course, because a well-maintained infrastructure implies also a less dangerous infrastructure. So that's the point, but of course, as I pointed out in the slide of the strength and opportunities of the system, maybe in future an integration could be possible.
Okay, thank you. And yes, we are all road users, so I think it's an interesting project, even if it's for the time being, it's a feasibility study. And I would like the opportunity also to thank those who have answered to the survey. Maybe amongst the listeners today, there are some of them who have filled the survey, and this is one part of our work that we have done up to now. The second question is, what kind of analysis has been done to assess that the system is not safety critical? So not SIL4, at least.
Yeah. For what concerns this analysis, we have performed a safety analysis based on the legislation IEC 61508, which is basically the legislation for assess the safety requirements of a systems. It is basically characterized by risk matrix. The risk matrix is given by two analyses. The analysis of the likelihood occurrence of the major failures of the systems, and an analysis of the consequences of these major failures of the systems. Thus, what we have done, we basically we defined all the major failure of the systems, which basically are almost all related to a poor GNSS and internet coverage. And we classified the likelihood of occurrence based also on a state-of-art analysis of internet and GNSS coverage. And basically from this analysis, it resulted that all those major failures are tolerable or acceptable. So we don't have any major failure which is unacceptable or undesirable. And basically, according to this legislation, if all the major failures are tolerable and acceptable, basically the system is non-safety, provides non-safety services. And also we did also an analysis of the context of this kind of failures. I mean, if road users are not warned of the presence of level crossings or some issues going on at a level crossing, there is not an increase of risk for road users, but just the risk remains the same as the system is not available, like right now. Of course, if the system, the services of the system are available to road users, the risk decrease. Thus, major failures does not imply increase of risk for road users.
Okay. Can you just say 2 words in order to answer to the following question? How are you expected to monitor the railway traffic for the optimization of road user route based on an active level crossing closure?
Yeah, for what concerns this service, we thought about external providers. Of course, such external providers are not accurate, but the aim of the system is not to say to road users the exact time of the train approach. But the main aim is to just tell road users that a level crossing is likely to be closed. So it's just a probability. And based on this probability, road user can optimize their route.
Okay. Now, are you working designing under infrastructure technical specification for interoperability, operation and traffic management, TSI?
Okay, no, right now we just defined user needs and user requirements. We defined a high level of architecture, and then in the next step we will define and work on the drawings of the architecture of the system. But anyway, as I said, we don't expect any integration in the railway system.
Perfect. And how, yes, but perfect for the moment because it's also a feasibility study. Let's see
Of
after
course, because
what will come out. Yes.
Yeah,
Last
there is
question.
the predisposition of the system to be integrated.
Yes. Last question, for the moment at least. How do you manage false alarms?
Okay, for what concerns for alarms, we managed it through, of course, internet coverage and through the cloud-based architecture of the system. In fact, the applications of road users have to be connected to internet and thus connected to the server, because the server then processes all the informations that are sent to the application. So it's just through internet, but also through GNSS. Of course, GNSS is a key technology because can, let's say, provide the position of road users and make the system aware of the, let's say, vicinity of the road users from the level crossings. And thus, it's a very important technology to send important information to road users, such as the distance from the level crossings, then the velocity with which the road users is approaching the infrastructure. Thus, I can say that the main means which the alert services are managed with are GNSS and internet.
Thank you, Francesco. There is a question that continue to come in the chat. Maybe we take Lutz for the end of the presentation, the webinar, or we do it now?
You can do it now. The last question for now. Yeah.
Last question, Francesco. 1 minute for answering, not more. Are you using digital models to define the specification and requirements of the overall system? So digital models.
Okay, no, actually we didn't use digital models because the requirements and the user requirements and system requirements are not exceeding big numbers. So there we have just a few systems requirements. Of course, this is just a feasibility study, and maybe in future requirements could be even increase, become several more, and then we would need, in this case, digital means to manage the requirements.
Thank you very much, Francesco. I hope that your answers satisfy all the those who have raised the question. I give back the floor to Lutz for the second part, the second speaker.
Yeah, thank you, Francesco. Thank you, Guido. Certainly, you will still have the chance to use the chat function for your questions for the first presentation and also for the next presentation which follows. Yeah, LiveEO is a Berlin-based startup, and I read starting with 200 euros, and now LiveEO has over 100 persons in their staff, and they mainly dealing with Earth observation and observation of critical infrastructure by using satellites. And there is also at minimum one application case performed with Deutsche Bahn, and Gemina Escaris will report or will present these use cases, and we are very excited to hear your presentation. Gemina, it's your turn.
Thank you very much. Good morning, everyone. It's a pleasure to be here. Thank you, Lutz. I would like to share my screen if that's possible. Yes. So, thank you very much. As Lutz mentioned, my name is Jimena Escaris Di Blasi. I'm an account executive here at LiveEO. I'm super excited today to present the satellite analytics that LiveEO is preparing together with satellite data and artificial intelligence to enhance railway safety and operations. Just to start, I would like to give a brief introduction about LiveEO. LiveEO is an Earth observation company leading the European market nowadays. LiveEO counts with more than 130 employees from different 30 countries around the world. The headquarters of this company is based in Berlin, Germany, but it also has companies in the US, UK, and Latvia. LiveEO had secured already $30 million in fundings, and it's already serving 60 utilities and transport customers in 60 countries in 5 continents. What you're able to see in the down part side of this slide is just the selection of some of the customers that are already trusting in our solutions. And below to that, it's the strong partnership relationships we have built to make these solutions possible nowadays. So yeah, I would like to start presenting today how you can monitor railways from space based in 2 very useful use cases that we have delivered to our customers. So first of all, we know that controlling the vegetation alongside the railroads, it's becoming a very, very important topic. The main issues that railway companies are facing nowadays in these regards is the safety hazards, infrastructure damage, and operational disruptions. We know, and just a selection here of some of the last news, train collisions had happened because of the trees falling into the railways, trains also delays because of falling trees, and train incidents just because the visibility was not a good one, since a lot of density vegetation was affecting the view in this case. One public report from the network Rail says that 19,000 vegetation-related incidents were happening between 2017 and 2019, leading to an over 1,750 cancellations. And this has a direct impact on economics, which means 100 million pounds a year that costs due vegetation-related incidents, which is, of course, a very alarming numbers. Now, the question is how to be able to monitor thousands of trees across 2,000 of kilometers alongside your railway tracks. We know, based on conversations that we had with, of course, nowadays our customers, that there is some ways to monitor the railways, but there are also some limitations that these methodologies are bringing. The first is the limited scalability. It's very difficult to cover thousands and thousands of kilometers of lines with only one of these systems. Also, because it's very expensive to use it, it's also asking a low frequency that most of the times in regards to vegetation makes that the vegetation needs to have a cycle of monitoring based on this expensive cost applied to the monitoring solution. Of course, this has an impact on resources intensive, and in the end, it's also bringing some poor data management. It's very difficult for these companies to get all the information together and have a bit like a backbone of all the information together, the one that collects to the field and the one that allows them to have action into the issue as such. And based on all of this analysis is how LiveEO had created the tree-line solution, that is basically the vegetation management solution that I would like to present today to you. Basically, this solution is tackling these main issues. It's a solution that is scalable, is timely, is accurate, is holistic, and is accessible. And I would like to go point by point into these ones. When we talk about scalability, it's because you are able to monitor your entire network in once at any time that you need. Doesn't matter which part of the world it is located, and doesn't matter how big it is. In this case, and just as an example, for example, we analyzed Deutsche Bahn complete entire network in Germany, and this is covering 34,000 kilometers of line. When we talk about time, the reality is that nowadays with the technology that satellites are providing us with, we can have a near real-time coverage every day in every part of the world. Accuracy. Our solutions are bringing between 80 and 90% of accuracy that it has been tested on every project that we deliver to our customers. It's always going with the validation on the fields that allows us to understand the accuracy that we're getting in terms of where the vegetation is located and exactly all the information that we are able to gain through satellite images. Holistic approach. As I mentioned before, we are able to detect where vegetation is located, but we can also add to these different intelligence layers, I would say, that allows you to understand better what is the situation, the status with the vegetation, but also allows you to have an overview in the future where this improvement of the vegetation going. And what are these layers? We can also deliver the height of the vegetation, meaning that the falling risk can also be added to these analytics. Health of the vegetation, meaning the vitality. How vital is this vegetation? Is it dying or not? The species of the vegetation. Some contractors, subcontractors want to understand if we're talking about a hard wood tree or a soft wood tree. This also allows them to understand which is the tools that they need to bring to the place in advance. The density of vegetation, that it might be affecting the right of way. And as I mentioned before, all of this can drives you to understand what are the growth patterns that this vegetation will perform in 3 or 5 years ahead. Accessibility, we always deliver all of these results with all of these layers of analytics that I mentioned through a LiveEO web application. We also have a mobile application that will allow, for example, subcontractors to have access to this task, even though they don't have internet connections. We know that sometimes there are some places that internet connection can be a bit tricky, so they can also be using this app without internet connection. And also important to mention, we are able to integrate these results in any platform that is of the customer choice. Yeah, we can do this through SAP, for example, ERCI, or any other maybe that the customer has in use nowadays. It's just a matter to sit down with our technical team and try to understand how we can integrate this. And as I mentioned before, the idea is not only to have these analytics and see it in these beautiful maps that are very useful, but it's also a matter to understand how to act after we understand which is our risk. So the entire procedure that LiveEO does, it's from end to end, it's starting with the satellite image and information, the georeference information of the grid. All these analytics, all these layers of intelligence are gonna drive us to generate tasks that can be divided in high, medium, or low risk tasks, based, of course, on what the customer understands as a risk. This is completely customized for you to have exactly what you need. It needs to be done on the field. And when I talk about the different layers, we can provide you with a growing risk. This is the basic one. It's basically the distance, horizontal distance from the vegetation to the line. Then we can also add the falling risk. This is adding the height of the vegetation, and the algorithm will provide you with an analysis that it's going to take into account the height of the vegetation, the height of the tree, and it's going to provide the falling risk, meaning that it's going to make the calculation of, in case that this tree is falling, which is the probability that will have a direct impact to the rail cross or not. Hazard trees, basically, it's the analysis of the vitality of this vegetation. As you can see here, let me check with my, here, we have different colors. The red color is showing high morbidity, meaning that all this area is the trees that are dying. It's maybe most probably not the human eye is not able to analyze this. But what we do is we combine images of satellites from today in the past 5 years, and we put all these time series steps to understand exactly what is the performance of the vegetation. We know that the different, the summer and the spring and the autumn, it's making the vegetation have a particular performance. If something in that performance is breaking, the algorithm will understand that the tree is most probably dying. It's going down in vitality. And this is what we're going to detect in this map. These are the colors that you're seeing, from red to green, high morbidity and low morbidity. And basically, this is super powerful when you combine it with the height of the vegetation, right? Because if I have a tree that it's dying, it's already dying, and it's tall enough to fall into the grid, immediately the algorithm will create this task that I mentioned before as a high-risk task because we are having a hazard tree in that specific area, which is super powerful for railway operators. And last but not least, also we can provide you with an analysis of fast-growing and invasive species for you to understand which are the areas that requires more action. And yeah, as I mentioned, this of course has an impactful results. You are gonna enhance safety on all the works that subcontractors need to do on the field and attack everything that means a risk for your lines. Increase operational efficiency, improve reliability, achieving sustainability, and secure a quick ROI, return of investment. And also, I would like to mention another solution. It's also a bit in relation with vegetation, but it's a solution that we call Surface Scout Rapid Response. And basically, this is the LiveEO post-storm damage detection solution. So this means that it's a solution that will inform you about any change that had occurred after a storm. That can, for example, be a tree that falls into the railway. Basically, also for our report, we know that the annual cost of weather-driven delays, it's around $10 million. And based on this, disaster responders basically are facing the challenge of covering very big areas. They have the difficulty of knowing exactly how to prioritize the effort. It's very difficult for them to understand where they need to go first. And it's very challenging at the moment of communicating within different teams inside the organization. Based on that problems, LiveEO has created this post-storm solution that is based on a change detection solution. So for this, basically, we use a different technology. It's not optical. We use SAR technology, which allows us to have a 100% of observability. This is a technology that allows us to see through clouds, and it doesn't matter if we have or not light, meaning that we can also take images even though it's a night. This solution basically works on what we call a change detection. Basically, the algorithm needs to compare one image pre-storm and one image after the storm. And by combining these two, can understand where the changes have been allocated and exactly detect where people need to attend these changes on the field. Which is also interesting is that this allows us to cover very big areas from thousands of square kilometers. And very, very powerful is also that we can deliver these complete reports for you to understand where you need to send crews on the field in below 12 hours. And again, how we deliver this, it's a mobile application and web application. I would like you to present some customer stories. We have worked together with Deutsche Bahn and AWS, which is the cloud that we use to run our analytics. I would like to share with you this very interesting video, please.
Wir stellen deutschlandweit 34.000 Streckenkilometer von den Alpen ans Meer.
But climate change is becoming an increasing threat to that infrastructure. So what we're looking at is, in the case of a severe storm, if a tree were to fall, would it risk falling onto the train tracks?
Die Vegetationsinspektion machen wir derzeit zu Fuß und das sind Abermillionen von Bäumen.
But with AWS technology, we can take the data from the sky, from the satellite, from space, to look at things in a different way. I never thought I would be in a space-related field. I've never watched Star Trek, but it's very interesting now that I'm here. At LiveEO, we take raw satellite data and turn it into something useful. So looking at 34,000 kilometers worth of track means we have a huge amount of data. The AWS cloud gives us this ability to quite quickly be able to store large amounts of data as we need. And then we apply machine learning models to that data, then provide it to Deutsche Bahn.
Von LiveEO erhalten wir verschiedene Geo-Packages, die eben beschreiben, wie hoch und der Baum ist und wie der Abstand zum Gleis ist. Und die haben wir dann eben auch transformiert in Risikopolygone. Und das sehen wir in verschiedenen Farbtönen von niedriges Risiko bis hohes Risiko. Und dann berücksichtigen wir aber auch da auch die Expertenmeinungen von unseren Kollegen vor Ort. Und hiermit stellen wir sicher, dass die Bäume mit dem höchsten Risikopotenzial als erstes behandelt werden.
Wir haben verschiedene Teams, sind alles Holzfäller verschiedenster Art. Also wir bearbeiten hier einen Kiefer- und Lärchenbestand, der mittlerweile eine zu hohe Höhe erreicht hat und damit, wenn er denn fällt, in den Gleisbereich fallen könnte. Nachdem wir die Fällungen durchgeführt haben, arbeiten das Holz auf und legen das in Benjeshecken ab. Das ist eine Renaturierung, um Habitate für Tiere zu schaffen.
Ich denke, der Wald ist schon ein sehr wichtiger Bestandteil der deutschen Kultur. Die Natur zu erhalten ist ein großes Ziel insgesamt. Wir wollen CO2-neutral werden als Land in ein paar Jahren und da ist es wichtig, dass wir auf die Bahn zählen können.
We can't prevent the weather. However, what we can do is provide resiliency. So what we're working towards is a 10-hour response time, which means that really you can have a storm overnight and then in the morning already have people clearing the tracks and getting trains moving again.
Der gesamthafte Überblick, der ist einfach fast unbezahlbar, den wir da aus dem All bekommen. Ich denke, da sind wir einfach auf neue Technologien angewiesen, um den zukünftigen Generationen einen lebenswerten Planeten zu hinterlassen.
Sometimes we think about the space industry and it can all seem like lots of pipe dreams, things that you just are never going to see within your lifetime. And what we're really showing here is that it's possible to use space and technology to protect what we already have and make things better here on the ground.
Und wir stellen
Perfect. That is just one of our customers. We also run a pilot with a major railway operator in Europe. Again, the objective was to improve the way they were doing vegetation management. And the scope of this work was the vegetation classification and also encroachments and the falling risk analysis, meaning that we also had the 3D analysis, the height of the vegetation. And one important also scope of this work was that the customer wanted to understand when the cutback was done, meaning that they wanted to be secure that the subcontractor did the cutbacks on the field. And for this, we also applied the change detection analytics. And this allows us also to have a clear overview when the cutback, where the cutback was applied. And this, the customer were using in order to pay to the subcontractors, which is something also very, very useful to manage the complete cycle of vegetation management. Then the question maybe will be why LiveEO, and we would like to highlight these 4 models that all the product is bringing to our customers. So first of all is the technology. The LiveEO has created this deep learning tech stack that it's applying for the best use to our customers. It's also created a stable data pipeline. And I think one of the main goals here is, as I mentioned before, is not only having the raw data of the satellite, but being able to understand exactly the insights, intelligence of what needs to be done, the action in the task. The data that we work, so we can have a global coverage, and we work with a very strong partnerships in data suppliers that allows us to make this possible. The insights that we deliver, as I mentioned, it's very fast to value insights. We can also deliver in a very user-friendly, as I mentioned, platform, but also the possibilities to integrate these results in SAP, S3, or Trainbill, for example. And we also have API integrations. And security, which is a very, very important topic nowadays. We are SOC 2 Type 2 compliance, and also for some customers, the servers can be also situated in the customer geography. This is also one option for some areas that this is required nowadays. And yeah, basically in a very small end-to-end sample here of how we work. So everything starts with the satellite data. We need to combine this with the georeference information of the railway. We run this in the artificial intelligence created by LiveEO, and we gain these critical assets tasks to have an action on these issues and deliver to our customers a preventive management of these risks. And again, the users can have a use of the platform, web or mobile, in a very, very easy way to do it. Yeah, I think that's everything from my side now. If you would like to see a demo of this solution, I will be more than happy to do so. You can scan this small QR here, and you can book direct a meeting with me in my calendar. It will be a pleasure. Thank you.
Yeah, thank you very much, Jimena, for your very interesting presentations. And as you can expect, we have some questions collected into the from the chat. And this is the slide with the questions. And first, I come to the first one. In what ways can satellite-based vegetation monitoring contribute to environmentally sustainable vegetation management practices for railway companies?
Mm-hmm. Well, in this case, I would say that there is two main pillars for sustainability. The first one is to be able to attempt the vegetation that means a risk for the infrastructure and leave everything that doesn't mean it's a risk. Most of the times with different customers that we have been working, we realize, as I mentioned before, that vegetation most of the time has a cycle of maintenance, which means that, for example, every 2 years, everything alongside the right of way needs to be cut down in order to be able to have a clear area, and after 2 years come back again. The idea with the use of LiveEO and satellite data is that this cycle needs to be moved into a condition-based maintenance, where you are able to detect only that vegetation that means a risk and cutting this one and allowing the rest to be part of the ecosystem in a healthy way. And the second one is the reduction of the CO2 emissions. If we compare the impact that satellite has, for example, comparing with helicopters, is quite considerable amount.
Yeah, the second question, what cost benefits can railway companies expect from adopting satellite data and AI for vegetation risk management?
Yeah, I would say that cost benefits is very much related to the inspections, the way that they do inspections nowadays. It's going to be reducing these manual inspections, and of course this will create an optimization of the schedules they have nowadays, and yeah, everything I would say will drive to operational excellence.
Yeah. Third question, what role does AI play in analyzing vegetation risks for railway infrastructure?
What AI did you say?
What role does AI play in
AI.
analysis? Yeah, AI. Yeah.
Yeah, sure. Well, I would say that AI is a key element here, since we're working with a very big data, and this wouldn't be possible to work with all this very big amount of data without AI. And also I would say that AI allows us, as I mentioned before, for example, when we analyze the vitality of vegetation, AI is very key element here because allows us to see what actually the human eye is not able to detect. So yeah, I would say, and also I can add that artificial intelligence, it's always like willing to, we can always give more information to make make it more intelligent. So as soon as we move forward with different customers project, we gain more insights and we make it, yeah, bigger in the capabilities it has.
Mm-hmm. Yeah, the next question, can you provide more details on how the tree species are determined?
Mm-hmm. Yeah, so for species, we have two ways. The simple way will be to differentiate between coniferous and deciduous. The algorithm is already trained to differentiate between these two types. And this is the basic differentiation between hard tree and soft tree. So this will be like a very easy way in these two differentiations. Then the algorithm can also be trained to identify a bit deeper, like we can detect up to 10 different species of trees, but this really needs to, we need to receive data that can train the algorithm with the specific species that it's allocated in your region. For example, our algorithm right now is very much well trained for all the species that are growing in the different areas in Germany because of Deutsche Bahn project. But if we're working in another region, we need this type of information to be able to train the model with that specific species. It's completely possible, but it's very much important, the data that we use to train the algorithm.
Yeah. Next question is, how do you consider the uncertainty of each map product derived by satellite data?
Can you read it again, please, Lat?
How do you consider the uncertainty of each map product derived by satellite data?
The product. I'm not really
Of
sure
each
about
map
this.
product, each map product or produced derived by satellite data. Oh.
Hello? Could I explain the question?
Yeah.
It was from me. Yeah. Hello. Hi, Jimena.
Hello.
Thank you for your talk. Very interesting. I mean, each map that you produce with satellite data has some uncertainty. No? The classes are not 100% that class. Or if the tree is at risk, maybe the people going to the field and face a tree that is not at risk because it was not an uncertainty in the algorithm. How do you consider that? Or do you deliver that also as a product?
See, so very good question, actually. So to try to tackle this maybe false results that can happen, of course, what we do, how we work in LiveEO, every project that we deliver, everything starts with a pilot, yeah. And as I mentioned before, the pilots always finish with a validation on the field. So we travel to the area, to the specific where we did the project, and we do the validation report, meaning that we at least take different 100 points alongside this project, and we validate each of the points, and we try to see there if there is any of these false detections. We try to gain this information to retrain the algorithm to be very specific on the region. It can happen, yeah, it can happen because vegetation is different in each region. So what we do is we take this time to travel, to validate it, and to correct the algorithm based on what we collected on the field. Did I answer your question?
Yes, thank you very much.
You're welcome.
Next question, and we have some questions left, and I opened a second slide for questions. Next question, does LiveEO cover any region or is it limited to the EU?
No, we cover every region. We have been working in the South America, Central America, the United States, Canada. So yeah. It's global coverage.
Next question, can you see an object falling on the track during the night? Which is the minimum size?
Very good question. So we work with two different resolutions, 50 centimeters resolution for this type of solution or 3 meters resolution. I would say that the object can be between 50, 80 centimeters, and it will really depends which is the material of it, how much it will reflect. But I would say that around 80 centimeters can be detected. Yeah.
Yeah, and also during the night.
Yeah,
Yeah.
during night is not an issue because we work with SAR technology, which it's not working as an optical. This works with microwaves, so it really doesn't matter if we have or not light.
Yeah. Next question, could the system be integrated or connected to the rail traffic management systems, for example, to provide alarms in the case of issues after a storm?
This is something that I need to double check with our technical team. It's a very, very interesting question. I don't know who is the person, but I can
Francesco, the presenter before. Yes.
Francesco, perfect. Let me discuss it with technical team, and I can come back to you. Yeah, sure. Very good question.
Yeah. Next question.
Thanks.
Sure.
Next question. Could you provide an example or overview on costs? How much does your customer needs to invest to monitor, e.g., 100 or 1,000? I guess 1,000 kilometers of railway.
Yeah, that's a very good question. So I don't have an overview of cost. I can't tell you like right now the price per kilometer because it depends on a lot of factors, right? As I mentioned, there are different type of analysis. If we're talking about the 2D, 3D, if we're going to include vitality or not, species or not. And also we need to understand which is the criticality that you consider as such. If you want to detect things in less than 50 centimeters, for example, distance to the line, or with 3 meters will be enough. And I'm saying this because here we're talking about different resolutions that we're going to use for that. Based on your 100 kilometers or 1,000 kilometers, this looks like 100 kilometers could be more range price of a pilot project, when 1,000 kilometers is more on the pricing of what we call rollout, which of course, as more kilometers to be analyzed, the less the cost, right? So I don't know who is the person, but I would love to have a conversation, and maybe with more of these details, we can come back with a proposal and a pricing for sure.
Yeah. Maybe the provider of the question is indicating his or her email address into the chat, or get in direct contact to Limina, and then we can further discuss. Yeah, which satellite data do you use? I understand it's mainly VHR data, but from which constellation provider, Maxa, Worldwide, or others?
So yeah, for SAR in these some projects, yes, it's no, it's Capella we use. We have other use cases when we use Sentinel, of course, and for optical, we are working with Planet or App42, depending on resolutions.
Yeah, from which satellites do you take the data?
From which satellites? So
Yeah.
most of the times is a SkySat from Planet, or a Planet Dove, and App42, Pleiades Neo. Yeah, I don't remember the name of satellites from. I said Sentinel-1 from the open source, and I don't remember the satellites from Capella, but I can come back to that information also, of course.
Yeah. Next one, and I want to close the possibility to raise questions, because we have so many questions to be answered. Do you develop algorithms for increasing the resolution of free EO images?
We have been working with free EO images, so the Sentinel one, up to 1 meter or less. I'm not really sure. I need to also double check with our technical team. I can come back to this one. Yeah.
Yeah. Do you see benefit in integration of below ground soil moisture data obtained by L-band SAR with your real-time data?
Yeah, for sure. Very, very, very beneficial. Yeah, when we talk about growth modeling, for example, this can be very beneficial. Yes.
Yeah, and the very last question, do you see any competitors in the market?
There are some, of course, but I would say that, yeah, LiveEO is quite strong nowadays based on, yeah, our customers, ecosystem and partnership. So, yeah, but of course it is, yeah.
Yeah. In case you have some more questions, we will provide you with the email address as well from Francesco and from Dimena, which takes you in a position to get in contact with them to clarify some open questions. Thank you, Dimena. Thank you, Francesco, for these interesting presentations. Thank you to the audience for the interesting questions, and I will give you the chance, the audience, to give some comments on this ERCI webinar by using our feedback questionnaire. Only some questions. It takes you 2 minutes, and it gives the presenters an idea of the quality of the presentation, or of their presentation, and gives us the possibility to learn more about the topics you are interested to hear for future ERCI webinars, so that we are not going more and more boring, but interesting to you. Please use this link, and maybe Guido could put this link into the chat. He did it already for the moment. Then some of the ERCI clusters are engaged in a project called Success to support European SMEs of the rail supply industry in successfully applying to public procurements in USA, Canada, and Norway. And there are some Tenders Watch newsletters of these three countries available, and you can easily ask Ms. Vescu or Ms. Ruiz de Loizaga or Ms. Espirou for receiving these Tenders Watch newsletters from the USA, for Norway, and for Canada. Then we have a STARS B2B matchmaking platform that's coming from the STARS project. It was to support European enterprises to adopt advanced technologies for their businesses. And you can still register, you can still have meetings with already registered participants all around the clock. It is possible, only you have to set up a small profile, maybe update your profile, maybe also to define what you are offering or what you are searching, and then finding maybe a good partner to have a first initial discussion of possible collaboration in certain fields of business. Then we will publish the ERCI webinars and also this webinar later on the YouTube platform of the STARS project. This is the link, and give us 2 or 3 days, and then it will be online and could be watched also afterwards. So, a hint to the next ERCI webinars, we will have the next one in 14 days, and that means on 14th of February, on AI for the rail sector, travelers' experiences and seeing machines. 2 interesting presentations, one from the ERCI GmbH, a company based in Saxony in Germany, and the second presentation from EURECAT, the Catalonian Research Institute. Very interesting. You can already register to this webinar, and you are welcome to have you on board. The next one is in 4 weeks, on the Wednesday of 28th of February, on norms and standardization for trackside equipment. And this webinar will be presented by a company coming from Italy, and already the registration is already possible. Within this link, you will already find some more details about this webinar. And we have also planned a webinar on the 13th of March. It's on ultra wideband for indoor positioning and mobility. The registration link is not available yet, but will follow soon, and we keep you informed. If you have any ideas for topics, please let us know and follow our short feedback questionnaire. The link is already in the chat. And the last point of our webinar, the last few minutes, is on short presentation on a project led by the European Railway Clusters Initiative. It's in Europe's rail project called LIDA 2030. And for that, I will give the floor to my colleague Guido from DTEC Fair to explain what is on this project. Guido, it's your floor.
Yes, thank you, Lutz. A few minutes just to explain Europe's rail project called LIDA 2030. The acronym, behind the acronym, the title of the project is Learning for European Autonomy to Deliver Europe's Rail in 2030, which means tomorrow. What we are examining, next slide, please. In fact, we summarize this with this slide where is written out of stock. Why? Because it will be a problem. It could be a problem. And we would like to make sure that in the railway, for the railway project, now defined and developed and designed in Europe's rail, we will be able to deliver what has been developed now. So just to take the example about the lesson of the pencil of Milton Friedman, because it seems incredible, but it's true. The components to produce a pencil are coming from 10 countries. Why? Next slide, next. The graphite is coming from Mexico. Then we have wood, aluminium, next, rubber, and lacquer. So you understand that several of those countries are away from here, and the difficulty is to collect all the information and the material in order to produce a pencil. Do you imagine which is the impact for a railway system or subsystem? Next slide. So the tender, a call has been launched by Europe's Rail, and we answered to those keywords: supply chain, needs of the future. Next.
Yeah, sorry.
Constraints, disruptions, availability of raw material and components. Next. So, in fact, what we have a lot of issues or problems coming out in the next months and years, and we need to know if we are able to produce what has been developed and conceived in this phase in Europe's rail projects. So the fact is that we have faced, all of us, disruptions, and our companies are telling us that maybe they will have difficulties in finding raw material, lithium or other, because this is what they are facing now. Imagine in 6 years. So the reduced availability of materials and components, but also the concentration of the production abroad. And you see in the bottom of this slide, the area of the world from where those raw material and components are coming. Then we have to consider also the climate changes. In the top, in the bottom right image, you see that the area which are subject to climate changes and impacting mines and other production sites will have some risk of disruption for European production. Then we have also to consider the new EU directive on corporate sustainability due diligence, which will make additional supplier difficulties in finding raw materials and components. Next. So the composition of this consortium, which has answered to the call and win the project, Leader 2030, is managed by ERCI plus Rhenanium, the French research institute based in Valenciennes, JKZ, which is our partner knowing everything on mines, based in Saxony, in Freiberg, and we are the fourth member. His partner is Technopark Istanbul, which will bring his knowledge in other systems and other sectors, because we are not alone as railway in the world having needs. So in any case, we will have to understand which are the priorities in order to satisfy the needs coming from our sector, but also respecting what is coming from aviation, automotive, or other needs. So we started this project of 30 months, Leader 2030, which is a study of the past in order to identify alerts of the future. We are still in this phase for the time being, but in the other, we are also analyzing the demand side and detailing which is coming out from the general documents of Europe's rail in order to be able to determine the supply side in terms of raw material, in terms of quantity and type of raw material and components which will be needed in the near future. So this will bring point 4 to the forecast of actual availabilities and the gaps and the bottlenecks, and to deliver a final analysis report and recommendation to the European Commission through Europe's Rail in order to define trade agreements or other solution in order to cover those gaps. Next. So in order to be able to collect which are the disruption, which are the problems, which are the issues that companies, big and small companies, are facing now or have already faced, in order to collect those experiences, we have defined a European online consultation. We have done it in several languages, and you can see the QR code there. The data are treated with confidentiality, so the results are anonymized and regrouped. So it's important that all of you, if you are faced or you think that you will face some problems, give your idea, your experience, because this will be a way to try to find solution, propose ideas and recommendation at a higher European level. So the QR code are there and will be put maybe also in the chat. Next slide, Lutz.
Yeah. Sorry. Yeah.
So, just to be 4 minutes late, I tried to run explaining Leader 2030, but certainly all of us involved in this project, we are available in order to give more details and try to give answers in order to work together and deliver this project on time for our future. Thank you.
Yeah, thank you, Guido. In minimum, I put the link to the project website into the chat. That is a part of the ERCI website, and there you find some additional information on these Leader 2030 project, and you will find also the link to the survey there. and yeah. And Guido took the chance also to put some versions of the available versions of the survey into the chat, so that you easily can follow by your mother language or in English if your mother language is not covered, because it depends a bit on which languages are covered via ERCI. That's not all languages of the European Union, but some selected ones. And I guess your contribution as a business covering the railway sector is very interesting to know if you had in the past some difficulties with your supply chain, yes or not, and if yes, with which material, and this is a very valuable information in order to further develop the supply chains of the future, or to investigate what alternatives could be established, what measures has to be established to overcome these gaps. So thank you very much, and thank you very much all of you for your attendance. We will meet again in 2 weeks with that AI topic for the next ERCI webinar. You will receive a follow-up email with all information, with the presentations, with the contact data of the presenters, with the link to the video to be seen at YouTube, and all the best to you, and see you soon in 2 weeks. Have a nice day. Bye bye.
Bye bye.